The newly released Mythos model and results from Anthropic are quite fascinating, really. Um, we're seeing a lot of open source vulnerabilities getting disclosed. Luckily, those are getting fixed as well. I think Mozilla Firefox just had like 271 CVEs reported and fixed. Not all of those were from Mythos, I think, but a significant portion were. And as we look at kind of embedded software, there's kind of two real kind of challenges for device manufacturers, software manufacturers in the embedded space. First and foremost is there's a lot of open source in the embedded ecosystem, whether that's OpenSSL or curl for crypto and web communication. Even if you're talking about RTOSs like ThreadX or FreeRTOS, you're going to have some open source there outside of just the RTOS usually. But also as you look at, a lot of embedded devices now are running Yocto or Zephyr Linux, where there's a ton of open source coming in through that supply chain. And so those embedded devices are really hard to patch. It takes a long time to get those updates out there. Usually on average about 6 months for vulnerabilities to get from disclosure to patch being available, much less fielded. So as we think about this kind of dramatic shift in how many vulnerabilities are being found in open source software, those are just the ones that we know about today. There's going to be a bunch of these AI vulnerability reports, whether they're from Mythos or uh, some of the other models from OpenAI or Google or others. Even some of the local models now are finding good vulnerabilities. Those are going to be able to get targeted at devices as well. Not just the open source there, but all the proprietary operating systems, the proprietary software that's running. And that's going to create, kind of this tension in needing to patch faster and do more patches while at the same time needing to ship new features or bug fixes or performance improvements for those embedded devices and those software pieces. And the security teams and the product managers are going to be stuck trying to triage all these vulnerabilities. How many of them are true positives? How many are false positives? And it looks like the data from the Mythos reporting has been good, but we don't know how much of that was filtered out as bad reports that the model produced that maybe never made it to an open source developer or made it to a device manufacturer, software manufacturer. So as this kind of ramps up, device manufacturers are really going to have to get back to uh, best practices around secure software development lifecycle, and that's great. Leveraging AI tools for code review for security review can be super helpful, but at the end of the day, you're still kind of plugging individual vulnerabilities or individual security problems before they get shipped and become vulnerabilities. And so device manufacturers really need to look at how they can take whole classes of vulnerabilities off the table, whether that's using good SQL frameworks in their web applications or database operations so that you don't have SQL injection attacks. Using appropriate web frameworks for preventing cross-site scripting, or as you get to more of the low-level embedded code, the assembly, the C, C++, even in some cases the Rust and other memory safe languages, taking a look at what technologies can you deploy that can help you take whole classes of memory safety vulnerabilities off the table. That's obviously one thing where RunSafe Protect is really good at, but there's other technologies that can help that as well, right? I mean, we talked to a lot of device manufacturers today where everybody's running as root on the device. All the software is privileged. Or they just assume that every input and output's trusted, so you got to kind of work on that. But those things are piecemeal fixes, but where you can, you should apply solutions that are going to give you good protection across whole categories of vulnerabilities instead of just individual vulnerabilities.